Okay, this is exercise number 35 on page 276, and in this exercise we're supposed to show that this binomial 3 plus the square root of 5 and this binomial 3 minus the square root of 5 are both roots or solutions to this equation, meaning that if I substitute this value in for x, it makes the equation true, and then again if I do it with 3 minus root 5. So I'm going to frame this as x squared minus 6 times x plus 4 equals 0. And first I'll substitute in the 3 plus root 5. And then I'm just going to simplify and see if that makes the equation true. So 3 plus root 5, I need to make this a little darker. 3 plus root 5 times 3 plus root 5 is, it's always the pattern. So it's going to be the first term squared, so 9, plus 2 times the product of those two, so 2 times 3 times root 5, or 6 root 5, plus the last term squared. So when I square the square root of 5, I get 5. And then I have a minus 6 times 3 here is 18, and then a negative 6 root 5 plus 4 equals 0. So when I go to simplify this, the positive 6 root 5 and the negative 6 root 5 will cancel each other out, and I'm going to have rational 9 plus 5 is 14, plus 4 is 18, and a negative 18 is 0. So indeed, 3 plus the square root of 5 is a root. So I'm going to do the same thing with the other root and prove that that makes the equation true. So I'm using 3 minus the square root of 5. So when I multiply 3 minus root 5 by 3 minus root 5, I get the first term squared minus 2 times 3 times root 5, so minus 6 root 5, plus root 5 squared, which is 5, minus 18, and then negative 6 times negative root 5 is positive 6 root 5, plus 4 equals 0. And you'll see that this is very similar to the last exercise right up here, except that these have opposite signs in a different order, but they cancel each other out. And again, we have 9 plus 5 plus 4 is a positive 18, minus 18 is 0. So that is also a root, and it's been proved by substitution.